Hello, my name is Ana Claudia. The proposed title for my thesis is Advancing InSAR Monitoring and Algorithm Optimization for Continuous Deformation Analysis. I count on the support of my supervisors, Professor Joaquim, Professor Matus, and Professor Antonio. Techniques such as labeling, EDM, and GPS are used for deformation detection and monitoring. However, these techniques are expensive, time-consuming, and have a lot of environment and weather limitation. With InSAR, it is possible to mitigate this limitation, allowing to obtain more information, high accuracy, high spatial resolution, and obtain data day and night. SAR uses a directional beam and advanced signal processing techniques to combine information from multiple radar signals and thus estimate target position. By capturing these measurements from multiple locations as the sensor moves, SAR synthesizes a large aperture, allowing to obtain high-resolution image. InSAR involves the use of two satellite SAR images acquired over the same area at different times or at different acquisition geometries. In general, InSAR analysis aims at measuring surface deformation by tracking change in the sensor-to-target distance after removing possible effects. The first image will be the reference for images of the same area that are carried in slightly different perspectives. A pixel-by-pixel cross-multiplication of the first SAR image with a complex conjugate of the slave is generated. InSAR uses multiple SAR images acquired over the time to measure continuous ground deformation. This technique requires continuous monitoring tasks and representing an advance on the first generation of SAR data processing. PS are points on the Earth surface that maintain reflective characteristics in a set of radar images. They are usually parts of buildings, metallic structures, or rocks. Among the millions of pixels, there are several thousand that show the stable phase in the entire time series, and these points are used as a reference. This is a multi-temporal processing of Vila Real. The points that we see on the map are the PS points, and it is possible to observe the displacement speed of each point over the time. In this type of processing, it is necessary to process all the images of the time series to be analyzed, with 10 or hundreds of images, and each InSAR image normally have between 4 and 5 gigabytes, so this processing needs a lot of memory and have a high computational cost. So, one of the challenges in MT InSAR analysis is managing and processing large volume of data and high computational costs. The solution is using automated workflows for data storage measurement, processing, and simplified data measurement tasks. The main objective of my thesis are establish a simplified processing for updating time series data without processing all data from beginning, and development of a multi-temporal InSAR model as a tool for monitoring risk zone with detailed information. This work plan predicts 5 main work packages planned for 3 years. The work 1, literature review and identify research question. The work 2 is what I'm doing now with use of software for multi-temporal InSAR, identify and exploring existing datasets and other methodologies. The work 3 is develop and perform multi-temporal InSAR processing with a new approach. In work 4, I will validate and evaluate the approach developed, and work 5 is writing the thesis and publish articles. The host institutions for my work plan are UTAD, INESC, and Slovak University of Technologies. The curricular plan, I choose the options of image processing and computer vision, and advanced topics of digital signal processing. I'm going to present my graphical abstract. The MT InSAR requires continuous monitoring tasks and representing an advance on the first generation of SAR data processing. However, this technique have high computational cost and need to processing large volume of data. There are several areas where it is necessary monitoring deformation, such as urban areas, infrastructures, or volcanoes. These monitoring scenarios will be selected based on identified challenge. European institutions have invested a lot in developing a monitoring system based on InSAR, which is a testament of the technical importance. The European Ground Motion Service provides a ground motion information for various applications, but it is a early updates with a temporal lag of about 6 months, and this information is at a small scale. So, at the end, will development of a multi-temporal InSAR model as a tool for monitoring risk zone with detailed information updating time series without processing all data over the time for risk zone and taking account of the software and technology already developed.